Hi, good morning students. This is revision lecture for class 12th and today we are going to discuss whatever we had studied in last week in live classes. We're just going to revise it, okay? So, the first thing where we start the differentiation of logarithmic function. Logarithmic function. Okay. So in this you know very well. We consider an example from this. We are just going to understand. Let y is equals to x to the power sin x, and we need to find difference dy by dx for the function. So, first we taking log on both sides. On both sides we have log y is equals to log of x to the power sin x. Okay. Now log y can be written as sin x into log x. Now differentiating on both sides we get 1 upon y dy by dx is equals to sin x, differentiation of log x 1 by x plus log x, differentiation of sin x is cos x. Okay. So dy by dx, this is nothing but y into sin x by x plus cos x into log x. Put the value of y, you will get the answer. Okay. Now we see another question which is very important. So see, sometimes they have given the sum of two functions. Okay. So in this, suppose y is equal to x to the power sin x plus cos x to the power x. Okay. So this type of question is very important. Students are doing the mistake like that, log y, log of x to the power sin x plus log of cos x to the power x. Okay, this is wrong. Understood why? Because log is not distributive over plus. So what we need here, we need taking this as u plus v, and then dy by dx is nothing but du upon dx plus dv by dx. Okay. So for this particular function, u is what? X to the power sin x, and v is what? Cos x to the power of x. Now separately we find du by dx from here and dv by dx from here, and put these values in equation number 1 and we get the answer. Okay, maybe you understand this one. Now we are going to discuss next topic, differentiation of parametric function. Differentiation of parametric function. Okay. So differentiation of parametric function. Differentiation of parametric function. You know very well what is parametric function. For circle it is x is equals to a cos theta and y is equals to a sin theta. Why? Because if you add square and add these two equations, you will get the equation of circle as x square a square cos square theta plus y square is a square sin square theta. If we add x square plus y square, this is a square cos square theta plus a square sin square theta. So this is nothing but x square plus y square is equals to a square cos square theta plus sin square theta, and this is nothing but x square plus y square is equals to a square. This is the equation of circle. Since this parametric forms gives you equation of circle, that's why this is parametric equation of circle. Similarly, we get parametric equation of parabola, hyperbola, etc. Okay, so now we see differentiation of these type of parametric equation. So how will we get? Suppose we have given equation as x is equals to 80 square and y is equals to 280, then find dy by dx. So first dx upon dt, this is 280, and dy by dt, this is 2a. Now dy by dx is nothing but dy by dt upon dx upon dt. Okay. Okay, so this is 2a upon 2at. This is cancelled out 1 upon t. So dy by dx, this is nothing but 1 by t. So this is the differentiation of parametric function or parametric form. Okay. Now we are going to discuss the differentiation of a function with respect to another function. Now differentiation of a function with respect to another function. Okay. Now we see the differentiation of function with respect to another function. Differentiation of a function with respect to another function. In this also we consider an example as differentiate sine inverse x with respect to tan x. So this is the question. So we consider two functions as dy y1. y1 is sine inverse x and y2 is tan x. Now dy1 by dx, this is nothing but 1 upon root of 1 minus x square, equation number 1, and dy2 by dx, this is nothing but tan x, this means sec square x. Okay, and now this is equation number 2. Now what we need, dy1 upon dy2, and this is dy1 by dx divided by dy2 by dx, and this is nothing but 1 upon root of 1 minus x square into sec square x. So the differentiation of the function sin inverse x with respect to tan x is 1 upon sec square x root of 1 minus x. Okay. Now next one is higher order derivatives. That means only second order derivative in your syllabus. So we are going to discuss second order derivatives. So, see, first we see y1, that means d by y is equal to fx be a function, then y1 is dy by dx. Okay, so y1 is first order, y2 this means d2y over dx2, this is second order derivative. This means d by dx or dy by dx. So y2 is nothing but second order derivative. Second order derivative, okay? And it is nothing but what? Y2 is nothing but d2y over dx. Suppose we have given a function as y is equals to sin x plus cos x. Y is equals to plus cos x. Then find d2y over dx2 we need to find. Then this is nothing but, first we find dy by dx, then this is cos x minus sin x. And d2y over dx2, this is nothing but dy by dx of dy by dx. And this is what? dy by dx of cos x minus sin x. And this is what? Minus sin x minus cos x, then this is nothing minus sin x plus cos x. Sometimes we put it as y and we get d2y over dx2 is nothing but minus y, then d2y over dx2 plus y is equal to 0. This is the proof. Suppose y is equal to sin x plus cos x, then prove that d2y over dx2 plus y is equal to 0. Okay, now in this chapter the last topic is Rolle's theorem and mean value theorem. So let us see the statement of Rolle's theorem and mean value theorem. Now, first one is Rolle's theorem. Rolle's theorem, okay? So, what is Rolle's theorem? First, we consider let fx be a real valued function. Real valued function. Okay. First, fx is continuous in closed interval a. Second, fx is differentiable in open interval AB. Okay. And third condition is fa is equals to fb. Then there exists C belongs to open interval AB such that f dash C is equal to 0. This is statement of Rolle's theorem. Okay. Similarly, statement of mean value theorem. What is mean value theorem? Okay. mean value theorem. Mean value theorem. Okay, so see, again we consider let y is equal to fxb, a real valued function. fxb, a real valued function. Then first one, fx is continuous in closed interval AB. fx is differentiable in open interval AB. Third condition is, then there exists C belongs to open interval AB such that f dash C is equals to fb minus fa divided by p minus a. Okay. So this is the statement of Rolle's mean value theorem. Okay, so this is the statement of mean value theorem. So in this manner we have to complete the differentiation part. Now in 6th chapter, application of derivative is started only rate of change of quantities. So this is the chapter 6. Application of derivative. In that chapter, we have only started the rate of change of quantities. So 6th chapter is application of chapter number 6. Application of derivative. Application of derivative. In this we had already studied the rate of change of quantities. Rate of change. So what is rate of change? Suppose S is displacement, then ds upon dt, this is the velocity and this is nothing but rate of change of displacement. Okay, rate of change of displacement. And as you know, we had already discussed some questions based on this rate of change of quantities. In that, some questions of the type as lake, we drop a stone, then the waves increasing in the form of circle. The rate of increment of circle is something, then find the rate of change of the radius. So rate of change of circle means rate of change of area in the circle. Area of circle, that means pi r square. Similarly, we see some questions of the type, suppose we have a balloon, okay, in which we just find the rate of change of surface area, volume, rate of change of volume is given. So many types of question is that exercise. So please try to understand and solve. So thank you for today. I hope you understand. Thank you.